Hey everyone, and welcome. Today we're jumping into a really critical topic in object-oriented programming, and that's Java exceptions. And listen, mastering this isn't just about fixing bugs, it's about learning how to write professional, solid code that doesn't just fall apart when something unexpected happens. So let's get right into it. So let's kick things off with a question that I know every single one of you has asked at some point. You spend all this time writing your code, you finally hit run, and poof, it just crashes. It stops working. Why does that happen? And maybe more importantly, how do we as developers get ahead of these problems and stop our entire application from just dying? Well, the answer to all of that lies in what we're going to cover today: exception handling. Here's a quick look at our game plan for today. We're going to start with the absolute basics, what an exception even is. Then we'll look under the hood at something called the call stack to see how Java actually keeps track of errors. After that, we get to the fun part, getting hands-on with try and catch blocks and walking through real code. And we'll wrap it all up with the finally and throws keywords before a quick review. It's going to be a packed session, so let's get started. All right, let's dive right in. Before we can even think about handling exceptions, we need to have a crystal clear understanding of what they actually are. Trust me, this is the foundation for everything else we're going to build on today. First up, by the end of this, you're going to be able to effectively use exceptions in your object-oriented programs. This means going way beyond just writing code that works sometimes. It's about building strong applications that can handle problems when they pop up. මේ පාඩම ඉවර වෙනකොට ඔයාලට පුළුවන් වෙනවා object-oriented programming වලදී exceptions කියන දේ ඊටම ඵලදායීව හරියටම පාවිච්චි කරන්න. ඒ කියන්නේ නිකම්ම කෝඩ් එකක් ලියනවට වඩා ප්‍රශ්නයක් ආවොත් ඒක හරියටම කළමනාකරණය කරගෙන program එක කඩාගෙන නොවැටි පවත්වාගෙන යන්න පුළුවන් විදියට කෝඩ් ලියන්න. මේක තමයි professional developer කෙනෙක්ව beginner කෙනකින් වෙන් කරන ප්‍රධානම දෙයක්. Next, you'll be able to confidently explain the concept of exceptions in Java. And I don't just mean for an exam, but for a future job interview when they ask you about it. ඒ වගේම Java වල exceptions කියන්නේ මොකක්ද කියන සංකල්පය ඔයාලට පැහැදිලිව විස්තර කරන්න පුළුවන් වෙනවා. කවුරු හරි අහුවොත් exception එකක් කියන්නේ මොකක්ද? ඒක වැඩ කරන්නේ කොහොමද? Errors සහ exceptions අතර වෙනස මොකක්ද කියලා ඔයාලට හරියටම උත්තර දෙන්න දැනුම ලැබෙනවා. මේක විභාගයට වගේම industry එකටත් හරිම වැදගත්. And of course, the most important part, you'll get the hands-on skills to actually handle exceptions in your code, turning what could have been a total crash into a controlled, manageable event. අවසාන වශයෙන් programming කරනකොට එන exceptions handle කරන්න. ඒ කියන්නේ ඒවට මුහුණ දීලා program එක crash නොවි ඉස්සරහට ගෙනියන්න ඔයාලට ප්‍රායෝගික හැකියාව ලැබෙනවා. මේක තමයි අද පාඩමේ ප්‍රධානම අරමුණ. අපි බලමු මේ දේවල් කරන්නේ කොහොමද කියලා. Okay, so what exactly is an exception? Well, the official definition is that it's an event that disrupts the normal flow of a program. Just think about it like this. Your code is running perfectly, line by line, just like you planned. And then, bam, something unexpected happens, like a roadblock on a highway, and that normal flow just comes to a screeching halt. That's an exception.
හරි එහෙනම් අපි මුලින්ම බලමු exception එකක් කියන එකේ විධිමත් තේරුම මොකක්ද කියලා. සරලවම කිව්වොත් exception එකක් කියන්නේ program එකක් සාමාන්‍ය විදියට පේලියෙන් පේලිය run වෙමින් පවතිනකොට ඒ සාමාන්‍ය ගමනට බාධා කරන අනපේක්ෂිත සිදුවීමක්. හිතන්න ඔයාලා වාහනයක් පදරවාගෙන යනවා පාර හොඳට තියෙනවා හැමදේම සාමාන්‍යයි. එකපාරටම ටයර් එකක් පුපුරනවා. අන්න ඒක තමයි exception එක. වාහනේ සාමාන්‍ය ගමන එතනින් නතර වෙනවා. program එකකදීත් වෙන්නේ ඒ වගේ දෙයක්. ඒක සාමාන්‍ය ක්‍රියාකාරීත්වයෙන් පිටපණින සිදුවීමක්.
First, like we just said, an exception is basically an exceptional event that interrupts your program's normal, happy path.
පළවෙනි කරුණ අපි කලින් කතා කළා වගේම තමයි exception එකක් කියන්නේ program එකේ සාමාන්‍ය ක්‍රියාකාරීත්වයට බාධා කරන විශේෂ සිදුවීමක්. ඒක සාමාන්‍ය දෙයක් නෙවෙයි, exceptional දෙයක්.
Second, and this is a really important idea, exceptions should be handled gracefully. Gracefully is the key word here. It doesn't mean just letting the program crash. It means our code should catch the problem and respond in a smart, controlled way. Maybe by showing a friendly error message and letting the rest of the application keep running.
දෙවෙනි කරුණ exception should be handled gracefully. මේක හරියම වැදගත්. gracefully handle කරනවා කියන්නේ මොකද්ද? ඒ කියන්නේ program එකේ ප්‍රශ්නයක් ආවම ඒක අපඩේ නවත්තලා දාලා user ට තීරමක් නැති error message එකක් දෙනවා වෙනුවට ඒ ප්‍රශ්නය පාලනය කරලා සමහර විට user ට සමාවෙන්න ඔබ ඇතුළත් කළදත්ත වැරදි වගේ තීරුම් ගන්න පුළුවන් පණිවිඩයක් දීලා program එක දිගටම ක්‍රියාත්මක වෙන්න සලසන එක. අර වාහනේ ටයර් එකේ උදාහරණයේදී වාහනේ පාරෙන් අයින් කරලා ටයර් එක මාරු කරගෙන ආපහු ගමන යනවා වගේ.
And third, you've got to understand the hierarchy. In Java, every single exception and error comes from one parent class called throwable. Think of it as the top of the family tree for everything that can possibly go wrong. And under throwable, you have two main branches, exception and error.
තුන්වෙනි කරුණ Java වල තියෙන හැම exception එකක්ම සහ error එකක්ම throwable කියන class එකේ sub classes. එමත් නැත්නම් ළමා classes වෙනවා. මේකෙන් අදහස් වෙන්නේ Java වල ඇති වෙන්න පුළුවන් හැම ප්‍රශ්නයකම මූලය ඒ හැමෝගෙම තාත්තා තමයි throwable class එක. මේක inheritance hierarchy එකක්. throwable එකට යටින් exception සහ error කියලා ප්‍රධාන කොටස් දෙකක් තියෙනවා. අපි ඊළඟට බලමු මේ දෙකේ වෙනස.
Okay, this is a big one. People throw around the words error and exception like they're the same thing. But in Java, they are worlds apart. On one side, you have errors. These are the really bad, catastrophic problems that your program shouldn't even try to fix, like the computer literally running out of memory. Think of it like the entire foundation of a building collapsing. There's nothing your app can do about it.
On the other side, you have exceptions. Now, these are the problems our code can and should plan for and recover from. We are talking about things like a user typing letters where a number should go, or the code trying to divide by zero. These are problems we can actually manage.
අනික් පැත්තෙන් තියෙන්නේ exceptions. මේව තමයි අපිට අල්ලගන්න catch සහ කළමනාකරණය කරන්න පුළුවන් ප්‍රශ්න. මේව ප්‍රෝග්‍රෑම් එක රන් වෙනකොට ඇති වෙන නමුත් අපේ කෝඩ් එකෙන් පාලනය කරන්න පුළුවන් දේවල්. උදාහරණයක් විදිහට යූසර් කෙනෙක් අංකයක් වෙනුවට අකුරක් enter කරන එක. නැත්නම් බිංදුවෙන් බෙදන්න හදන එක. මේව අර ගොඩනැගිල්ලේ fire alarmයක් වදිනවා වගේ. alarm එක වැදුනම අපි ගොඩනැගිල්ලෙන් එළියට යනවා ප්‍රශ්නේ විසඳනවා. ඒ වගේම ප්‍රෝග්‍රෑම් එකත් crash නොවි ප්‍රශ්නෙට පිළියමක් යොදලා දිගටම වැඩ කරනවා.
So here's the bottom line. As programmers, we handle exceptions to stop our program from crashing. We usually don't try to handle errors because they are way outside of our application's control.
ඉතින් මතක තියාගන්න ඕන ප්‍රධානම දේ තමයි programmersලා විදිහට අපි exceptions handle කරනවා program එක crash වෙන එක නවත්තන්න. අපි errors handle කරන්නේ නෑ මොකද ඒවා අපේ application එකේ පාලනයෙන් එහා ගිය දේවල්. Alright, so when one of these exceptions does happen, how in the world does Java know exactly where it happened? The secret to that is something called the call stack. Let's break down how this actually works.
The best way to think about the call stack is like a chain of command. Imagine a manager gives a task to a team lead, and that team lead gives a task to an employee. Let's see how that plays out in code. Call stack එක කියන්නේ හරියට වැඩලයිස්තුවක් වගේ. අපි එක සමාගමක තනතුරු දාමයකට සමාන කරමු. Manager කෙනෙක් team lead කෙනෙක්ට වැඩක් දෙනවා. Team lead ඒක employee කෙනෙක්ට දෙනවා. Then වැඩේ කරන්නේ employee. ප්‍රශ්නයක් ආවොත් employee මුලින්ම කියන්නේ team leadට. Team lead විසඳන්න බැරි නම් එයා කියන්නේ managerට. Call stack එකත් ඒ වගේ. First, your program kicks off, and the main method gets called. That's our manager. It gets placed at the very bottom of the stack. මුලින්ම program එක පටන් ගන්නකොට main method එකට call වෙනවා. ඒක stack එකේ යටින්ම තැම්පත් වෙනවා. මෙයා තමයි අපේ manager. Then, main calls method A. That's our team lead. Method A now gets placed right on top of main in the stack. ඊළඟට main method එක method A කියන method එක call කරනවා. මෙයා team lead. Then, method A එක main එකට උඩින් stack එකට එකතු වෙනවා. Next, method A calls method B. This is our employee who's doing the real work. Method B is now placed on top of method A, so method B is the method that's currently running. ඊළඟට method A එක method B කියන method එක call කරනවා. මෙයා තමයි වැඩ කරන employee. Method B එක method A එකට උඩින් තැම්පත් වෙනවා. Then වැඩ කරමින් ඉන්නේ method B. And now for the drama. An exception happens inside method B. The moment that happens, the JVM stops everything and creates a special exception object that holds all the juicy details about what went wrong and where. Now the stack starts to unwind. Java needs to find someone to handle this problem. It looks first at the employee, method B. If method B doesn't know how to handle it, it gets kicked off the stack, and the problem goes up to the team lead, method A. If method A can't handle it either, it gets kicked off, and the problem goes all the way up to the manager, main. And if nobody in that entire chain knows what to do, that's when your program crashes. මෙතන තමයි වැදගත්ම දේ වෙන්නේ. stack එක unwind වෙනවා. ඒ කියන්නේ උඩින් ඉඳන් පහළට එකිනෙක අයින් කරගෙන යනවා. JVM එක මුලින්ම බලනවා employee ගාව. ඒ කියන්නේ method B එක ඇතුලේ. මේ ප්‍රශ්නට විසඳුමක් handler තියනවාද කියලා. නැත්නම් method B එක stack එකෙන් අයින් කරලා ප්‍රශ්නේ team lead ගාවට method A එකට යනවා. එතනට handler එකක් නැත්නම් method A එකක් අයින් කරලා ප්‍රශ්නේ managerට main එකට යනවා. මේ කොහෙවත් handler එකක් හම්බුනේ නැත්නම් program එක crash වෙලා අර error message එකක් එක්ක එන stack trace එක print කරනවා.
Okay, so now we get it. We know what an exception is and how Java tracks it down using the call stack. So how do we actually handle it? This brings us to the bread and butter of exception handling, the try and catch blocks. You can think of this as your code's safety net. Let's talk about the try block first. This is where you'll put any code that you think is a little bit risky, code that might cause an exception. It's basically like putting up yellow caution tape around a piece of your code, telling the JVM, hey, pay extra close attention to what happens in here. Try block yakani, oyala hitana vidyada exception agek atiwenne idathiana aladanam code digadana thana. Hitanna oyala usergen input ekak ganwa, file ekak open karanwa, netnam network ekata connect wenwa. May devil asarteka vendapulan. Avoge code api try block ekak et the le lianwa. Aken api JVM ekata canwa, mennemi codec agena awadanin inna, methana prashnyak vendapulwan kila. Now, a try block can't live by itself. It has to be followed by either a catch block or a finally block. They come as a package deal. You identify a risk with try, and you provide a plan with catch or finally. Try block eka pano makan at the end ba. Aken passa any variant mat catch block eka kari finally block eka kari at the end maoni. Awadanam kalapayak nam karanem, aken arakshaka selesmak tiana maoni. And finally, it's good to know that one single try block can have several catch blocks after it. This lets you have different plans for different kinds of problems that might pop up. It could try block yakak ekada catch blocks kipiak tian napulan. Mugada ekama kodik halaka di vivida varge exceptions and napulan. Udaharnayak vidieta, file ekog kievin nakoda, file eket netivin natpulan, file found exception. Netnum file eka kievenda alvasara netivin natpulan, security exception. Itin ehama ekadama wenavenama catch blocks down napulan.
Now, for the other half of the team, the catch block. This is your safety plan. This is the code that gets to run only if a specific kind of exception happens inside that try block. Catch block eka kane arar arakshaka selesma. Try block eka etule prashneak again ne exceptioneakak avod viturak wedakurna code tikatamaya catch block ekitiane. Its whole purpose is to help the program recover gracefully. So inside a catch block, you can do things like show a user-friendly message, log the error for later, or maybe try a different approach. Anything other than just crashing. Mege aramana program eka crash when it ekanavasdala, eken godenna wadolkarna eka. Catch block agatule abrebuluan oba atulatkala anke vetter the akila user.message agaktenda. Erika file eka logranna, netnam wena vikalbakramak oksahakarana. And, like we said, you can have more than one catch block. When an exception happens, the JVM goes down the list from top to bottom and runs the very first one that matches the problem. And that's it. Only one catch block will ever run. Abikaling kiwa wage catch blocks kipiakti in the puan, exceptionekak awama, JVM ega uda indan pahalatek catch blocks tika check kurgane enoa. Exceptioneka type geta galapina pol of any catch block eka humbanamawan, eka execute kurla, anik catch blocks alkoma ignore kurnoa. Eka exceptionekakata, eka catch block eka veta kurne. This brings us to a super important rule. You have to put your more specific catch blocks before the more general ones. For example, you have to catch a specific arithmetic exception before you try to catch a generic exception. If you do it backwards, the general one will catch everything, and your specific block will never ever be reached. In fact, the Java compiler is smart enough to see that, and it won't even let you compile the code. May the hardem of aragat nityak dianoa, abi catch blocks lianakoda, visheshata, specific exception vorgeta odinode, poldu, general exception vorgeta polehinut lianda one. Udaharanak vitira, arithmetic exception ekeka, catch blockiak, exception ekakara kalinanda one. Mokoda hema arithmetic exception ekakma, exception ekak. Itin oyala, exception eka odin liwat, hema exception ekakma itinin alaganoa, yaratiana specific catch blockage kavadavat yannavenine. Ainasad Java compiler eka ewage code ekak compile karna denine, unreachable code, Kila Erika. Okay, that's enough theory for now. Honestly, the best way to really wrap your head around try and catch is to see them in action. So let's walk through a couple of Java code examples, line by line, and see exactly what happens when things go wrong. So here's our first challenge. The question is simple. What is the final output of this Java program? Let's take a closer look at the code. So here's the code. We've got a standard main method, and inside there's a try-catch block. Now look closely at what's happening inside the try block. We're trying to divide an integer by 0, and we all know from math class that you just can't do that. So let's trace this and see what the JVM does when it hits this line. All right, let's trace this. First, we jump into the try block. The line int a equals 10, b equals 0 runs just fine. No problems there.
මුලින්ම program එකේ execution එක try block එකේ ඇතුළට යනවා.
int a equals 10, b equals 0 කියන line එක execute වෙලා
A සහ B කියන variables දෙකට 10 සහ 0 කියන අගයන් ලැබෙනවා. මෙතන ප්‍රශ්නයක් නැහැ.
But then we hit the problem line. Int c equals a divided by b. The JVM tries to compute 10 divided by 0. It can't do that, so it immediately stops and throws an arithmetic exception.
ඊළඟට තමයි ප්‍රශ්නේ තියෙන line එක එන්නේ. int c equals a divided by b කියලා. මෙතනදී program එක 10 බිඳුවෙන් බෙදන්න උත්සාහ කරනවා. ගණිතයේදී බිඳුවෙන් බෙදන්න බෑ. මේක වළංගු නොවන ක්‍රියාවක් නිසා JVM එක ඒ මොහොතේම arithmetic exception කියන exception object එකක් හදලා throw කරනවා.
The instant that exception is thrown, the normal flow of the try block is over. That system.out.print line that comes after it, it is completely skipped. It will never run.
exception එක throw කරපු ගමන් try block එකේ සාමාන්‍ය ගමන එතනින් නතර වෙනවා. ඒ කියන්නේ exception එක ආපු line එකට පස්සේ try block එකේ තියෙන අනිත් කිසිම line එකක් මේ උදාහරණේ system.out.println result equals c කියන line එක execute වෙන්නේ නැහැ.
So the JVM immediately starts looking for a catch block that can handle an arithmetic exception. And what do you know? It finds one. Our catch, arithmetic exception E, block is a perfect match.
So, control jumps to that catch block, and the code inside it gets executed. System.out.println cannot divide by 0. The program successfully handled the error instead of crashing.
අන්තිමට
ගැලපෙන catch block එක ඇතුලේ තියෙන code එක system.out.println cannot divide by 0 කියන line එක execute වෙනවා. console එකේ cannot divide by 0 කියලා print වෙනවා. program එක crash වෙන්නේ නැහැ. ඒක exception එක handle කරලා සාමාන්‍ය විදියට අවසන් වෙනවා.
And so the final output that gets printed to the console is exactly what was inside our safety net, the catch block, cannot divide by 0. This is a perfect, simple example of how try-catch can save your program from a fatal crash. Perfect. Let's step it up a notch with a slightly more complex example. This one uses multiple catch blocks and a totally different kind of exception. So we've got two questions to answer here. First, what's the output? And second, what would happen if we messed with the order of those catch blocks? All right, check out this next piece of code. This time, we're dealing with an array. Inside our try block, we create an integer array that can hold 5 elements. And then right away, we try to put a value into the 10th spot. Let's trace this one carefully and figure out which of our 3 catch blocks is going to be the one to handle this situation. Let's trace it. The line int array equals new int 5 runs fine. It creates an array with 5 slots, which means the valid indices are 0, 1, 2, 3, and 4. Int array equals new int 5 kiana line eken, size eka 5 akava hari integer array ak hedanoa. Ekane, may array ake valangu index tna 0, 1, 2, 3 saha 4 with array. Then we hit the problem. Error 10 equals 50. The code is trying to access index 10, but that index doesn't exist. So what does the JVM do? It throws an array extents bounds exception. Ilangate, error 10 equals 50 kiana line ekade, programeka index 10 to access karan hadana, nomut arrayake upermia indexika 4. Make a neat the verdi kriyawak, any shaw JVM eka era extents bounds exception ekak thro karnawa. Now the JVM starts hunting for a handler. It checks the first catch block. Does arithmetic exception match? Nope, so it moves on. It checks the second catch block. Does era extents bounds exception match? Yes, it's a perfect match. Dein JVM eka handler eka koyana. Palavani catch block eka arithmetic exception. Galapeni nae skip karnawa. Divani catch block eka era extents bounds exception. Make a haryatemek elapinawa. So the code inside that second catch block runs, and it prints array index out of bounds to the console. Because it found a match, the third catch block is skipped entirely. Then because the exception was handled, the program continues, and the final line, systemout.printing elan, rest of the code, runs as normal. The full output is array index out of bounds, and then on the next line, rest of the code. Ithin devani catch blockika execute wela, array index out of bounds scale print wenawa, thunweni blockeka skip karnawa. Antimita, trikechekin iliatiana rest of the code kinalinika print wenawa. Now for that second question, what if we put catch exception E first? Well, that would be a huge mistake. Since exception is the parent class of basically all exceptions, it would catch this error. The more specific array extends bounds exception block below it would never be reachable. And like we said before, the Java compiler is smart. It will see this and give you a compile time error, saving you from your own mistake. Remember the golden rule, most specific first. So we've nailed the core concepts of try and catch, but there are 2 more keywords we need to add to our toolkit, finally and throws. These give us even more control and flexibility when we're dealing with errors. The finally block is an optional block you can add at the end of a try-catch structure. And here is the one single most important thing you need to remember about it. The code inside a finally block is guaranteed to run, no matter what. This makes it the perfect place for any cleanup code, things like closing a file or disconnecting from a database, because you need to make absolutely sure those things happen, even if everything else goes wrong.
finally block එක කියන්නේ try catch structure එකෙන් පස්සේ අපිට එකතු කරන්න පුළුවන් optional block එකක්. finally ගැන දැනගන්න ඕන වැදගත්ම දේ තමයි ඒක දෙන සහතිකය. finally block එකක් ඇතුලේ තියෙන code එක හැමතිස්සෙම execute වෙනවා. try block එකේ exception එකක් ආවත් නැතත් ආපු exception එකක් catch කරගත්තත් catch කරගන්න බැරි වුණත් මොන දේ වුණත් අන්තිමට finally block එක වැඩ කරනවා. මේක ප්‍රධාන වශයෙන්ම පාවිච්චි කරන්නේ clean up code වලට. ඒ කියන්නේ ෆයිල් එකක් ඕපන් කරා නම් ඒක ක්ලෝස් කරන කෝඩ් එක, database connection එකක් හදුවා නම් ඒක ක්ලෝස් කරන කෝඩ් එක වගේ දේවල් finally එකේ දානවා. එතකොට ප්‍රෝග්‍රෑම් එකේ මොන ප්‍රශ්නේ ආවත් අන්තිමට රිසෝස් එක රිලීස් වෙනවා කියලා අපිට 100% විශ්වාස කරන්න පුළුවන්.
This slide really drives home that guarantee. Let's look at the 3 possibilities. First, the happy path. Everything works, no exceptions. The try block finishes, the catch blocks are skipped, and then the finally block runs. Exception එකක් නැති අවස්ථාව මේක තමයි happy path එක. Try block එක code එක සම්පූර්ණයෙන්ම sort කරව execute වෙනවා. Catch blocks ඔක්කොම skip වෙනවා. ඊළඟට finally block එක execute වෙනවා. Second scenario, an exception happens and we catch it. The try block fails midway through, the right catch block runs to handle it, and then the finally block runs. Exception එකක් catch කරගත අවස්ථාව. Try block එකේදී exception එකක් එනවා. ගැලපෙන catch block එකක් එක අල්ලගෙන execute වෙනවා. Catch block එක over to one out of passe, finally block ek execute වෙනවා. And the third, worst case scenario. An exception happens, but we don't have a catch block for it. The program is about to crash. But even then, right before the program dies, Java makes sure that the finally block gets to run one last time. It's a really important safety feature. Exception එක catch කරගන්නක බැරි වුණව සාවා. Try block එකදී exception එකක් එනවා, නමුත් ඒකට ගලපෙන catch block එකක් නැහැ. Program එක crash වුණව thing අගලින්, finally block එක execute වෙනවා. ඊට පස්සේ තමයි program එක crash වෙන්නේ. මේක හරිම වැදගත්. program එක කරගෙන දරන්නේ නවලවදී Java අපේ cleanup code එකට වැඩ කරන අවස්ථාවක් දෙනවා. And last but not least, let's talk about the throws keyword. So sometimes a method might cause an exception, but it doesn't really make sense for that method to handle it. The throws keyword lets a method basically declare right in its signature, hey, just so you know, I might throw this kind of exception. It's like passing the responsibility up the call stack. It's an employee telling their manager, look, this task might cause a problem that I'm not allowed to fix, so I'm warning you now. If you call me, you need to be ready to deal with it.
throws keyword එක අපි පාවිච්චි කරන්නේ method signature එකේ ඒ කියන්නේ method එක define කරන තැන. මේකෙන් අපි කියන්නේ මේ method එකේ ඇතුලේදී මෙන්න මේ වගේ exception එකක් එන්න පුළුවන්. නමුත් මම ඒක handle කරන්නේ නැහැ කියලා. එතකොට මේ method එක call කරන්න ඕනෑම කෙනෙක් ඒ exception එක handle කරන්න වගකීම බාර ගන්න ඕනේ. ඒ කියන්නේ මේ method call එක try-catch block එකක් ඇතුලේ දාන්න ඕනේ. මේක හරියට employee කෙනෙක් manager ට කියනවා වගේ sir මේ වැඩේ කරනකොට මෙන්න මේ වගේ ප්‍රශ්නයක් එන්න පුළුවන්. ඒක විසඳන්න මට බලයක් නැහැ. ඒ නිසා මං කලින්ම දැනුවත් කරනවා. ප්‍රශ්නේ ආවොත් ඒකට මුහුණ දෙන්න ලෑස්ති වෙන්න කියලා. මේක exception handling වගකීම පැවරීමක්.
Wow, okay, we have covered a ton of ground today, from what an exception is all the way through try, catch, finally, and throws. So let's take a minute now to review everything and really make sure these key ideas are locked in. හරි එහෙනම් අපි සම්පූර්ණ පාඩමම එක වාක්‍යයකින් වගේ සරලව තේරුම් ගමු. ප්‍රෝග්‍රෑම් එකක් රන් වෙනකොට අපි බලාපොරොත්තු නොවන ප්‍රශ්න exceptions ඇති වෙන්න පුළුවන්. මේ ප්‍රශ්න නිසා ප්‍රෝග්‍රෑම් එක එකපාරටම නතර වෙලා crash වෙන එක වළක්ව ගන්නේ අපි ආරක්ෂක දැලක් පාවිච්චි කරනවා. ඒ ආරක්ෂක දැල තමයි try catch finally කියන structure එක. අවදානම් කෝඩ් එක try block එකේ දානවා. ප්‍රශ්නයක් ආවොත් ඒක අල්ලගන්න catch block එකක් ලියනවා. මොන දේ වුණත් අන්තිමටම කරන්න ඕන දේවල් finally block එකේ දානවා. මේ ක්‍රමයේ පාවිච්චි කරලා අපිට ශක්තිමත් විශ්වාසමත් programs හදන්න පුළුවන්. These right here are the absolute must-know terms from today's lesson. An exception is a problem at runtime. Throwable is the big boss of all errors and exceptions. The call stack is the roadmap that shows us where the problem happened. Try is for our danger zone code, catch is our safety plan, finally is our guaranteed cleanup, and throws is how we pass the problem to someone else. Make sure you're comfortable with every single one of these. And to help you get ready for any exams or tests, here are some really common questions you might see on this topic. If you can sit down and confidently answer all of these, then you know you have a really solid grasp of Java exceptions. Go ahead and use these to test yourself. Now let's just quickly go over 2 formal definitions that are great to have memorized for your exams. First, exception handling is just the official name for this whole process of responding to exceptions to keep our application from crashing. And second, the call stack trace is that big block of text you see when a program crashes. It's the list of method calls that acts like a trail of breadcrumbs leading you right to where the problem started.
You know, a great way to remember all of this is with a simple, real-world example, an ATM machine. The whole time you're trying to get cash, you're inside a try block. You're trying to complete a transaction. Now, what could go wrong? Well, you might not have enough money, that's an insufficient funds exception, and the machine has a catch block for that. Or maybe you typed the wrong PIN. That's an invalid PIN exception, and there's another catch block for that one. But what is the one thing that happens no matter what? The machine always gives you your card back. That action, ejecting the card, is in the finally block. It's the cleanup that's guaranteed to happen, whether you got your money or not.
And that just about wraps up our deep dive for today. We've learned how to deal with all the different exceptions that Java can throw at us. But that brings up a really interesting question, doesn't it? Now that you know how to handle errors, how can you create and throw your own custom exceptions to make your programs even smarter and more robust? Well, that, along with a close look at the difference between checked and unchecked exceptions, is exactly what we're going to explore in our next session. Thanks so much for joining, and I'll see you then.